Welcome back. In this video we will see what is the nodal displacement, support reaction and stresses in the element for this problem. In the last video session we are left with finding global stiffness matrix. Okay, K is equal to global stiffness matrix, Q is the nodal displacement vector, F is the force vector. Okay, we already know how we got this global stiffness matrix, and this is the nodal displacement vector q1, q2, q3, q4 up to q8. q1, q2 are the nodal displacement in the node 1 in the x direction and y direction. Similarly, q3, q4 for the node 2, q5, q6 for the node 3, q7, q8 for the node 4. And these are the force vectors 0, 0, 20,000. What is this 20,000? Let us see in the figure. Okay, see there. In the node 1, is there any force? No, there is no force in the x direction, y direction. So F1, F2 is 0. Similarly, there is no force, there is one force in x direction. So F3 is 20,000. There is no force in the y direction. So F4 is 0. And here, there is only one force. What are the forces in the node 3? There is no horizontal force. So F5 is 0. F6 is minus 25,000. And there is no forces in the node 4. So F7, F8 are 0. Okay, these values are substituted in the force vector. Okay, substituting all the vectors, global stiffness vector, force vector and nodal displacement values. Okay, we got this matrix. Okay, see here, by elimination approach method we already know that if nodal displacement values are known, then corresponding rows and columns can be deleted. What are the known boundary conditions here? Okay, see here, in the node 1 it is fixed. Node 1 it is fixed, so there is no displacement in the x direction and y direction. So q1 is 0, q2 is 0. So first row first column, second row second column can be deleted. Similarly, at node 2, this is roller support. Roller support means it can have the displacement only in x direction. So q4 is 0. So fourth row and fourth column can be deleted in the equilibrium equation. In the node 3, there is no constraints. In the node 4 again it is fixed. So q7 and q8 values are 0, known boundary condition. So 7th row 7th column, 8th row 8th column can be deleted. See here, q1 is 0, q2 is 0. I already told why it is 0. So first row first column can be deleted, second row second column deleted because it is fixed. q4, there is a roller support, so it can have only displacement in the x direction, not in the y direction. So fourth row fourth column is deleted. Similarly, 7th row 7th column, 8th row 8th column can be deleted. Okay, by deleting this is the elimination approach method. By this 8 by 8 matrix, it is reduced to 3 by 3 matrix. So what you can see, this blue color elements, okay, it is reduced to this 3 by 3 size matrix. So what are the unknown nodal displacements? q3, q5, q6, and it is left with the 20,000, 0, minus 20,000. okay, so you just solve this 3 by 3 matrix and find out these unknowns q3, q5, q6. So q3 is 0.04 mm, q5 is 0.00834, q6 is minus 0.03284. okay, these are the nodal displacement. q1, q2 is 0, q3 is calculated here, q4 is 0 because there is a roller support, q5 it is calculated here, q6 is calculated, q7, q8 as it is fixed, it is values are 0. Now nodal displacements are calculated here. First task is over. The next task it is need to find the stresses in the elements. Now we have 4 elements. For all the 4 elements you need to find what are the stresses and nature of stresses. For element 1, we already know this equation. It is already derived in the last video. Sigma is equal to E by L minus L minus M L M, and this is nodal displacement. Okay, for element 1, okay, Young's modulus value and length, Young's modulus it is same for all the elements, 2 into 10 raised to 5. This LE is the length of the element. For the element 1 it is 40. This L it is different. This LE it is the length of the element, this L it is direction cosine. Okay, direction cosine. We are finding this stress for element 1, so you consider it is L1 M1 minus L1 minus M1 L1 M1. So it is minus 1 0 1 0. What are the degrees of freedom? For the element 1 it is Q1 Q2 Q3 Q4. Already Q3 is calculated here. You substitute and find stress value. In the similar fashion, you find all the stresses for the remaining elements, sigma 2, sigma 3, sigma 4. Okay, this is length of the element. This 1 0 minus L, these are the direction cosines. Next, after finding the stresses in the element, the last task is to find the support reactions, K, Q minus F. K is the global stiffness matrix. Already we have this 8 by 8 size stiffness matrix. Q are the nodal displacement vector, and this is the force vector. You simplify it and find all the reactions. Okay, this is the problem number 1. Okay, this is the homework for you. You just you solve these 2 problems, example 2 and example 3. Okay, thank you.